Hello everyone, welcome back to this tutorial series. Um, in this part we will be finishing off the minor details of our tower, mainly focusing on the top floors and the glass balustrade. And those are basically the two main things that we'll be tackling. So let's get on with it. The first thing we're going to tackle is the floor, the roof terraces. If you remember correctly on Google searches, let me open this one for example, you will see, for example, in this render, on top of each of these block sections, there is this kind of a roof terrace uh, going on. So that's what we're going to recreate here. Now, the simplest way to do is to um, modify the extrusion of our um, core, which is the gray one. So if I zoom into the block one, if I highlight that, the green one is the core, and that basically comes from an extrusion from a boundary plane with a specific height, and this height was determined by the amount of floors that we have times the height of each floor. So the easiest way to do this is to minus the extrusion height that you see here of one floor. So let's track that back down here. We have the amount of floors and the floor height. Since these two components are not only used for our extrusion of the core, we will not be modifying that, but instead let's have a look at where we can modify it at the end of our results. So I would say between the z vector and the extrusion direction. So what we're gonna create a simple evaluate command. You can also do this with a subtraction, because what we will be doing is basically the height that we have here minus the floor height. So let's drag that all the way down to the y. First, simply extrusion will be x minus y, which is why you can also use a subtraction, which works fine. Now that we have the number, what we can do is we can just copy a z direction and use that one to drive our extrusion. So you can see now our extrusion is now well, the height minus one floor. But now this creates a problem because now our tower is basically like floating. So now we have to fix a few more stuff. And I think to do those fixes, we can move on to the next block, which is the above, because we know if you look at here, some of these columns, mainly the ones in the front, will have to run down a bit more. So that's what we're going to tackle. Before we continue, let's add our newly created components to the group so that they can stay if I move the group. Okay, so let's move on to this one. We're not really done yet with that, but we will come back to it and then tie it all together. So um, this part is not done yet, basically, the first part. Okay, so we're going to be doing the same here, except that now if you look at this one, actually, this is a little bit more simpler in the sense that we know on the top of the second block it needs to minus one floor, but if you look at the bottom one, it actually needs to move one floor down. So that creates a, well, you can actually see it as killing two birds with one stone. What do we have here? So we have the height. Actually, I might want to switch the panel to the height in this way because that's how we have it here, which is a bit more clear for our script. So we'll do the switch real quick. Let's see. So the data comes from here. What we need to do is actually swap that in there, swap the outputs of that in there, and then connect these two together. we have created a loop, so we need to get rid of that loop. And I believe this is our, I don't know what that is, but it's supposed to be our height. There we go. Okay. This is our extrusion for our core. So what we want to do is actually move this down by the floor height of 1. So let's just do a move component. We do need a Z direction, so we're going to copy one. Actually, I'm going to drag the Z all the way to our starting line so that I can easily connect it. I need the floor height, which is this one. So I'm going to connect that one here, and then I'm going to drag this back to where I need them. Drag that to the move. Now the floor height is positive, so it will move actually upwards instead of down. So you can actually connect this to anyone. You can actually connect this to the starting surface. But I would like to keep the surface where it is, even though I know I probably won't be using it anymore. But in order to keep our data as clear as, or as default as possible, because we started out on this floor, so it's best to keep that on that floor. And what we can do actually is either move the extrusion down. Yeah, that's the lesson. So we can just do that instead. We move the extrusion down, but we're moving it up because it's a positive value. So we need to apply a negative here so it can move downward. So we're going to do it on a T on the move. So do a negative X. And that will move it down by 1, which connects that floor and also serves us the for the next floor on top. And now I'm going to connect this to the geometry and add everything to the group. And then we have fixed that also. But we're not done with this yet because our column still needs to touch and we still need that green floor. So we're going to continue here. Our columns are the orange ones. What you might notice is not all the columns needs to be moved down. There's only a few sets, and if you look closely, it's actually these front set, excluding the start and the end, or how many it is that is excluded straight. Now, if you are remember correctly, we have the data sorted out for us, and that's actually residing in one of these components. So I believe this is not it, because as you can see, this one includes the last end. So I'm thinking it's this one, and it is. So I'm expecting here 2, 4, 6, 8, 9 values, and which I have 9 values there. So what I can do is actually work with this data. And the good thing about it is this data is already sorted in the sense that if you were to apply a longer straight section, the first 2 columns from each end might be excluded. It might match up with the one that's below, and if it does match up, then we don't need to extrude it or modify it for this purpose. So we're going to work with this data. These are curves, so we need to make it into a surface. So we can just copy that one. And now we need to extrude this down by 1 floor. So we can actually reuse our world axis that we've used here, but we do need a different extrude. So we're going to apply this one here. Since I need to use this in both negatives, I'm actually going to be putting the negative X in here instead of on the T. So I'm just going to get rid of that. I'm going to connect it here. And there's our columns. So I can actually now either merge these two. Oh, I don't know what I did there. Merge these two together. Or you can just plug it in here and bake them all together. Or you can merge it, soft merge. Or you can actually just solid union merge this together. Actually, let's see how that will work out. If it turns out to be a very heavy component, 4%, is that acceptable? outside the acceptable. So there we have it. These are our columns. Yep. Okay. Well, zooming in with my mouse causes some issues. I'm actually quite curious how they solve this in the actual build, because if I look at a photo here, I think I saw it. For example, this one, you can see that they don't align, so I'm pretty curious how they will solve that, or they will probably just leave it in there. But as it stands, you can modify it however you wish, or you can just leave it as is, which is also fine. I may not have explained this before, but the reason why we're trying to do this is not only to make the cowl right, but we're also trying to eliminate, if you were to bake this and you have overlapping geometries, this will cause issue for you. For those who are experienced with renderings in Rhino or in any 3D CAD software, overlapping surfaces can create a lot of issues for your renders. So we're trying to eliminate that. And that is more apparent in the next step. What we're going to do is we're missing a floor. So you might think, hey, then why not just, let's say block 2, we've said we want to skip floor. So if you were to type this to 0, you'll get your floor back. But if I were to select the floors, you see that they're all selected. And if I select the floors from the block below, which is the block 1, there's also selected. So they're overlapping, and the overlapping is already clear on my viewport. And if you were to bake this and try to render this, you will have issues. So what we want to do is merge either the top one with the bottom one or the bottom with the top one. So it's a choice that we have to make to say on which of these blocks are we going to include the floor. Like, are we going to consider that belonging to block 2, or are we going to consider the top one belonging to block 1? Now, because we are already moving from bottom to up, I would advise to move this floor, or this last floor, to block 1. So we're going to actually be eliminating it from to block 2, I'm sorry. Eliminating from block 1, but moving this top floor to block 2. So here's what we're going to do. Since this is our move, and that comes from a series of z-axis that defines how many times we're going to move our floors. So we can actually trace this back a little bit to our series, because this ultimately controls how many floors we're going to get. So instead of saying this is floor to skip on the bottom, but what we can do is, instead of we put this axis because we needed that one here, what we can do is we're going to eliminate that. We're going to set this back to not +1, just leave it as is. And you'll see that the floor disappears because we are not including the top floor anymore. Now, what we need to do is actually copy the outline of that floor, and then we need to find that by coming back in here, which I think is this one. So if I go back quickly to select it only. So we need to copy this to our upper floors. And one easy way to do that is obviously just take I actually want to take this one instead. Or I can just take the curve and then remake my boundary surface, which is also okay. But let's take the surface and see how that works out first. So I'm going to take that surface and I'm going to call this, I'm going to give it a logical name. I'm just going to call it block 1 floors outline. And I'm going to hide the connection line to make our code not too messy. And I'm going to put that also, or is that the one we already have? Wait, let me see. Nope, that's just the columns. So we do need this one. I'm going to add this to group. And now I have this geometry. What I can do is I want to move this geometry. Now it's at the bottom of our tower there. What I want to do is move it up to the level as the same as the bottom of our block 2. So let me identify where it is first. I think it should be in a later stage. This one. So what I want to do is I do want to say skip floor 1, but at the same time I want to do a region join, region union from, let me make some space here, from our original, actually let's make a merge instead, let's keep it clean that way. From our original, I might have to move everything a little bit to the side in order to give ourselves some space. I'm going to merge that with our first floor outline. Oh wait, no, I still need to move that up. So what I'm going to do, well, I want to keep it here, but I don't want to move it all the way there. So I'm going to just create a copy of the exact same thing. I don't need to hide the lines, though I don't need to see this, so I can hide those. I can also hide this one. But I'm bringing this part with me all the way here so that it's easier for me to work with them instead of just dragging up back and forth. Okay, so one thing we need to do is we need to make sure that this is on the same level as this one. We can easily create a move, which I think is this one. So we can actually do a move of that using our height vector. This is missing one floor. Aha. That's because this one was starting way lower. Okay, I have a better idea. I have a better idea. Let's do it this way instead. Let's do a so this is our surface. How many surfaces do I have here? Oh, that's a lot of surface. But I do know that this is the surface I need. So what I'm gonna do is I'm gonna just do a surface evaluate. We've been doing a curve value a lot, but we can also do a surface evaluate. This basically works the same as a curve. Instead of one dimension, you have two, so that's why you have an UV. So instead of a slider that's a singular number, you can do an MD slider, which is a multi-dimensional sliders, which gives you two. And the same works in here. So if X and Y or U and V is 5, and your surface were parameterized, you will always get the middle point. This is one way where, and then I'm going to internalize it because then I don't need to see this. This is one way in order to get a point on the surface, but since I only need a singular point, it doesn't matter what point, I can also do area, but I do think this component just costs a little bit more. In this case, it's quite okay because the area is very easy to calculate for the computer. So I would say pick one of these. They both work fine. Since this one seems to be taking a bit more space, I'm going to delete that actually and use the area instead. And what I want to do with this, I'm going to create a plane on this level, and I'm going to project my geometry onto that plane. So this is the plane, and this is the geometry I want to project. So I can hide all this. And this method basically ensures that, this is the reason why I also don't want to move the base where it should be. The projection method eliminates the need to give it an explicit height. It limits the need to very identify where it should be, whereas the projection can just be deriving your height from a component where the height is already correct. In this case, it's going to be the base of our core. So with that moved, I'm gonna put this back into the merge so that I can have these two together. I'll probably have to flatten this part so that I have these, and let's see how the merge turns out. I'm gonna actually go to plan view and turn on selected only. So this is what it looks like for our merged component. And there's a little kink here. That's because there was a column there that eliminates it. So this will eliminate our problem of having duplicate faces on top of each other. So the only thing we need to do now is, this is an for extrude down, so we can actually just copy this one and extrude one floor down. We don't need to extrude the whole floor, so that's fine. Oh, we do need to identify. We do need to boundary surface this, or you can actually just start with the line. That might have been better, actually. So you don't need. Oh, but that one is needed for that part. But that's okay. So we can just do this. We might want to do a Boolean union. Of, oh wait, they don't touch. These and that don't touch, so we don't have to do that. But what you can do is put them in a merge, just to make a little bit more cleaner when you bake. So when you bake, you don't have to select two components. You can just select the merged component, and you can bake everything in one go. So I'm just gonna remerge this together, and I'm gonna flatten that. Sorry, flatten this, I mean. And there we go. There's the line. I don't want to see that line. There we go. Now that line's gone. Okay, so now we've successfully fixed our sort of roof terrace. Now let's move on to the ones in the top. For the one to the top, what you can do is you can also either leave the block here, or you can actually do the same as we did in block 2, which is move the core down by one floor, which is this one. At least I can't find an image of that top floor, but I imagine that there is probably a top floor. Maybe, well, this is not that tower. I can't really find it. So I'll just assume that there's going to be one there. If there's not, then that's fine. Then we just, then we just not move it down, but instead extrude one floor down in that bit there. So that choice is up to you. But I do prefer to have the consistency of having a roof terrace on top of every different block. So that's what we're gonna do. So I'm just gonna put in a move here first, and I'm gonna move at the end. So I'm gonna create a Z, and I'm gonna drag it all the way until I find my floor height, which is this one. Floor height goes into here. I'm gonna drag this. I'm gonna keep on dragging it. And here I'm gonna do a minus because we want to move it down, not up. And we want to move our core, which is the gray one, like that. So we have now solved it for that part, and now we need to do the same basically for the columns and for that floor. For the column, it's easy. I think we have the same here, although it's a little bit different for this one because our selection is actually including only the what do you call it, the front part, this part. So we need to select actually 2 for these 5. And do we need to select this one? No, these are actually corresponding to the one below. So for this part, we actually need to define a different strategy in order to select those. You can probably, oh, let me remove this back into place. We can probably use some sort of smart sorting based on the floor that's below it. So I'm actually employing two strategy that does exactly the same thing, so you can see which one works for you that you might want to employ also for that one. But the logic that we use for that one is quite clear. I doubt that it will change, but for this one we do need to take a different approach. So that's what we're going to do, and we're going to analyze it, how we're going to do it, and then we're going to, well, start implementing our analyzed solution. Here's what we're going to do. We will take our the floor, the outline of the bottom floor that's below it. Whoa. And sort of make a comparison that say along the lines of, hey, if the columns, let's say we break down these columns into 4 points, if 2 of these points does not reside within on that line, then that means that the columns are not aligned to it. So for example, let me try my drawing skills again. So what I want to do is I want to extract the outline of our second block, which is going to be this one. Obviously it will run all the way, and I'm gonna say if 2 of these points at the corner falls on this line, then I don't want it. What that will do is it will probably eliminate these columns for me, and it will eliminate that column for me, and what I will get in return is going to be these columns, because they don't reside on that line, or at least uh, they might have 1 point that resides on the line but not 2 points, and that's going to be my um, my sorting process. And since I'm not selecting these, so these are not in the filtering process anyway, so I don't have to worry about those. So that sounds to me like a solid plan, so we'll have to put that into we'll have to implement that and see how that works out. So by first we have to get our outline from block 2. And where can we get that out? Actually, we can get that outline from here. We just need to identify it saying it's a different block. Or much safer is to take it from here. Or I can just say the block select -1. That can also do. In that way, we are actually keeping everything under from one input that's all the way in the beginning. So I think this is the main column outline, main section outline. I think it's this one. Let's have a look. We select it here. Okay, so we need to copy this one, and the I index will have the x minus 1, which gives us that outline. Now the only thing we need to do now is to move it in place, because these are at the bottom, or this one is at the top. Oh, because we already moved it. Well, that saves us the trouble. Okay. And now what I want to do is, in order to find out if these column resides on that line, I have to, let me drag it all the way up here actually. Oh, but I don't like these curves too much, so I'm just gonna create a duplicate component, and we're just gonna call this block 2 floor. Actually, it's the main outline, it's not the floor, main outline. Okay. Well, no, it can have a name like that. I'm gonna move this one. Where am I thinking? I think it will probably be manipulated somewhere around here, so I'm gonna drop it in here. Okay. So now what I can do is I am going to explode my curves, my colored curves. Well, exploding this one gives me how many vertex? 5, and that's because the start and the end is counted as 1. I can also just do a duplicate points remove using the kangaroo component, but what I can also do is say I'm going to use discontinuity instead. And what discontinuity does is it will split your curve on very sharp corners. And if you have not selected any of these two, you will have 4 points, like on this list here. So now what I want to do is I'm going to do, what is it? Include, or is it point inclusion? Point in beer. Actually, I might look at mesh surface analysis. Point in BREP. Well, it's not really point in a BREP. Perhaps it's in curve analysis. Yeah, this one. Point in curve. Test a point for closed environment, which we only have one. The other one tests for more, so we don't need that. So the curve goes in obviously there, and we have points structured by trees. So each tree has 4 points, which consists of the corners of or columns. Let's see what our data suggests. Let's take a look at the R. Okay, if you read the description here, it says 0 means outside, 1 means coincident, 2 means inside, and then we have the point projected on it. So what we can do with this is, in theory, okay, we all the let's say the columns that are fully inside our enclosure should have probably a value of 4 times 2, because if a point is inside, it counted as 2 points. You can read it as that. And if they're coincident, meaning they're sitting on that line, then they are and then there are 1 point each. So for our column that's sitting right at the let's say the column that we don't want, in this case, let me recenter my camera a bit. So for example, let me take a draw. For example, this column is likely we don't want, and we have 2 points sitting on it, which is coincident, and it gives us 2 points in the inside, which gives us 2 points each, which is plus 4. So this will give us a maximum value of 6, okay? While this, so let's assume that we have a column where 1 point is sitting right on the edge, which is fine, then we just can count it 1. And we have 3 that's sitting obviously inside. So it will be 3 times 2 is going to be 6, the minimum, okay? Because this one can either be 1 or 2. So we have, let me erase that instead because it's actually quite. So 2, 6, so 7. So what we can say, we can make a filter and say if the value is 6 or less. Well, that's not how you write it. For those of you who do mathematics, you're going to kill me for this. So if it's equal or less than 6, then I don't want it. But if it's otherwise, then I do want it. Or you can just say if a value is lower than 7, I want it, which works fine. So that's what we're going to do. Let me take that out. I'm going to move that. So in order to convert all these numbers that we have on the list into one single digit, what we're going to do is do a mass addition. This one. And I'm going to pull up a evaluate command. I might pull up a panel also. And I can already see I need a lot more space here. So I'm just going to actually, let's make that as my default color so I can recoup that later. I'm going to remove that. Remove it all the way up. These going to be moved up too. So suddenly my formula is going to be, give me that, it's going to be if x is smaller than 7, then I don't want it, which is false. If it is, then I want it, because that is true. I'm going to plug that in here. I'm going to plug this one in there, and I'm going to go out, and I should have a list of true false values that will help me if I call it by pattern. This is my pattern, and there are basically one column each per data branch. And since we flattened this part, actually we need this part instead. This one is including the back column, the main columns. Since this one is flattened, oh, I might want to move this up a little bit just so my wires are a little bit readable. So since I've already flattened this, I might want to flatten this one too, and I will flatten it here. And I can connect this one here, and I can hide everything except for that one. And you can see from my selection, I already have selected the ones that I really need. So now I can continue on the normal procedure, which is create a surface out of it and extrude it down by 1 floor height. Do I even have it here? Is that 1 floor height? This is 1 floor height. This is the one that we use to move our core down. So we can plug that in there, plug this in here, and there you have your columns. So I'm gonna also do the same as I did up, and I'm gonna do a union, solid union, flatten that so that they can be tied together. 17 column, and there you have it. I'll move this even more because now the other part comes in, which is from the floor. Okay, so I need to now find out where is, it's a different region. Is this one? Yeah, because this one is the floor that we need to combine it with. And I'm gonna copy, actually, what's the naming convention I used here? Just gonna copy that, and I'm gonna do a CRV. I'm gonna copy this into a curve. Actually, I didn't copy that curve. I copied it from that surface on the previous one, but it doesn't matter because in the end we saw that we also need to resurface that. So this time I'm just gonna copy this. You can actually correct it in this one also. This might be a good exercise for you to try to correct it yourself, and if you can make it work, then you probably understood that part. So for this, I'm just gonna copy the curve instead of the surface, and I'm gonna do the same thing here. I'm gonna put it next to this one. I'm gonna wire hidden. And we need to move that all the way, oh my god, all the way up here. And in the previous one, we made a projection plane. And the projection plane came from, I believe, this one, which is the base surface. So I'm gonna do in area, project that one. I'm gonna create an XY plane from that point, and I'm gonna do a project to plane, which is this one. That's my plane. I'm gonna drag this temporarily here in order to connect this, and I'm gonna hide that, and I'm gonna drag it back away here. I can actually probably move this a bit here so I have a bit more space to work with. Okay, now that we have our columns from the bottom one, I need to find, let's merge this. I'm gonna merge this one here, and the other ones I believe is this one. Actually, no, it's the, I want to move this one a little bit down. It's this one. It's way up all the way here. Wow. Mm, okay, I need some space in this one, so I'm just gonna nudge it a little bit like that, just like this. Okay, and now I can do a region union like that. This one needs to be flattened, of course. So now I can hide everything and I can check my results, which has this kind of look. Not bad. Okay. Oh, we forgot to do one thing though. We need to make sure that the block 2 floor is -1, so it doesn't include the top floor, which is this one. And we know that it comes from a series. Oh, this one comes, these are the one. It comes no from series, it comes from here, and that one has, so we need to remove the x plus 1, because we don't need that extra floor anymore. Okay, now that's settled, we can come back here and do a boundary. Extrude by 1 floor height, which is that number. We can reuse. Uh, let's do this instead. Because this one I can already see, judging by the number, you can see there the vector 0.5. I just remember that that is our floor thickness. So if you don't know, you can just track that back down and you can apply that one. Okay, so now we have to move, and now we can just need to merge. How are we gonna merge it? We're gonna merge it like that one, perhaps. You don't need these three. Just need to merge it down there, and we can probably flatten this part. And there you have it. There you have all the floors combined, and no duplicate faces. If you want, you can also combine all the columns together so that you don't have that. So, but in reality, your column is going to be probably the different color. But for these kind of parts, for these kind of exceptions, you're either off better doing a manual culling, or you just uh, slightly move your column back down a little bit, or you just combine those two together, which is also doable. What I mean by combining these together is you can, in the where is this one, you can also, before you plug it into this one, you can say I want the floor to be excluded from uh, the columns outline. So you can actually take the column outline here and do the same exclusion that we did here, so that you can get rid of that one. Okay, I think the top one doesn't need to do anything. So now what we're gonna do is we will first, I'm gonna actually group this again, and I believe there might be some loose item in there. Yeah, see, there's a lot of loose item in there. So what we're gonna do is select everything and add to group, so that they are in the group, and then they move together. So the next one we're gonna do in this part, in the last part of the tutorial, is we're gonna make a new parameter which we will call glass balustrade, and we're gonna utilize that in order to, well, make our glass balustrades. So that's the last thing we're going to be tackling in this tutorial. Okay, to start, we need to find a way to filter out the curve that we can use in order to generate a glass. And one way we can do that is using our floor outlines. So for example, let's track down a floor outline here. Of course, we don't need all the floors. What I suggest to do is do the same thing we do for one floor, and then copy it using that component right there. or the same strategy as just copy it to the floors that we have. But first we need our outlines, which I'm just going to use this to identify it, this one. So I'm just going to extract it away, and I'm gonna take it from the curve. That works a lot better for me. I'm gonna make a curve outline, and I'm gonna call this um, balcony outline. No, I'm gonna call this floor outlines. Yeah. So I'm gonna use a invisible connection, and obviously I will also need a main outline, which I think is this one. Yes. So I'm just gonna extract that also. Main outline. I'm gonna move this also to here and hidden. Okay, and I might not now might switch. Or should I switch? Okay, let's turn off the other floors. Let's focus on this floor, because once we have this first floor done, the other will be much more easier to do. I'm gonna disable my core. Yeah, I like that. I'll just disable everything basically. So now you have the outline. And what I want to do is I want to select the outer curve because that's where our glass will be. And what we can do that is we can actually explode all our curves, but we don't want all the inner ones. So we need to filter out the ones that are not on the outer edge that's overlapping with our main outline. So we're going to use the old tricks again, where we compare the distance of the curve, or to be specifically the center point of the curve. So we parameterize it, evaluate curve 0.5. Oh, something went wrong there. 0.5. Here we have a curve, and then we're going to do point closest to curve, or curve closest to point. And with this, I'm going to do an evaluate, and the evaluate expression will say if x is closer than a tolerance 0.1, then I would want it, because then it's true. Otherwise I don't. So if I connect the distance, which is the d here, and then I use a culling pattern for our exploded curve to the list, pattern to the p, there you have it, all our outlines. So with this, now what we can do is we can start to manipulate it a little bit. We can start to create a few parameters for ourselves. The first one, I would say, since your glass is probably not sitting on the edge, I mean, if you want it, it can. But let's just create a parameter for that. So we'll do 0.05 is smaller than 1. And what this parameter does is it offsets the glass where it starts from the edge. So we're going to call this offset from edge. Very, very original. I might do a number in between because we can probably reuse this for the other two blocks. So I'm going to just call it tap once, just so I can have the text. I might hide this for now. That's the offset. This is my offset curve. Okay, that's okay. This one offset to the outside. That means that we need this one's to be a negative x, so that offset to the inside. Now that we have this, we can actually copy this again, and then we're gonna call this glass thickness, which is again another offset. Let's start with 15. I'm not even sure if that's the one we want. We offset the curve that has been offsetted using this one. But this one will determine your how do you call it? Your glass thickness. Oh, we're actually in millimeters. We don't want to be in millimeters, unless you want to make a tower that's miniature. So we're gonna go to meters. So this means that this glass thickness now has a thickness of a whopping 10 centimeters, which mm, which is doable. I mean, yeah, it's doable. I think right now there's a project I'm working on that has a glass thickness of 1010, so 2 times 10, 20 millimeters. It's just quite thick. So for our purpose, we'll just drop that down to 15. I mean, it's adjustable. You can adjust it however you want it. And now, what we want to do is we want to merge these together. So if I zoom into an example, I don't need to see that one again. This one goes in here, this one goes in here. Make sure the data tree is okay. I don't need that one. What we want to do is basically this one to be grouped with its offsetted neighbor. And since our data tree is already, how do you say it, grouped in a way that it's, well, it's grouped in the right way. This is the way I want to say it. But actually, if I look at this, there is a tree that consists 2 elements. I want to explore that. I want to see why there's 2, because I'm expecting 1. Why would there be 2 curves in the same data branch, unless that's where they come from? I'm not expecting that. So I'm just going to go ahead and explore using a data tree branch. Simplify that, and I'm gonna see branch number 0, see what that is. Okay, so I'm selecting 2 curves. Oh, right, of course. When you explode a curve, we have a part of it that's straight, and that's why I exploded that part too. So we actually need to do something else before we all do all this, otherwise it will not go well for us. Actually, we can do it here. What we want to do is join the curves together, because I don't want to see two loose curves that can be joined. So we're going to join that, and we're going to plug that in. Nothing changes except that the curves that are next to each other are now joined to one item. And we can actually simplify this, and then you see the data structure is much cleaner in here. So now if I do a connect, and I'm pretty sure I need to flip one of these curves again, but we'll see. Yeah, exactly. Let's put this to position. Let's flip our curve. You know what? Let's flip the top one. Oh, data branch doesn't match anymore. So we need to, let's actually simplify this and simplify that one, so that we have one level of data branch, and this one also one level. So there's our glass, basically. And now what we need to do is to extrude this based on a glass height. Okay, well, glass height can be a little bit different. As low as 1 meter to, or actually as low as 0. Let's say 5 is 8 to 2.5 if you want to have that much glass. I'm gonna leave it at 1.1. Seems doable for me. And I'm gonna do extrude in the z-axis. Obviously doesn't make sense to extrude your glass horizontal. Interesting though. And that's gonna come in here, and there's our glass. And now I can enable my tower again. One thing I now need is the data that we use for our floor. So how am I gonna do this? We can, I think I might just copy it from this one here. Yeah, let's do numbers, not that one. Let's do a number. I'm gonna take that one, and I'm gonna call this floor floor heights. Does that make sense? Or if it doesn't make sense, just give it a name that makes sense to you. And then we have that. We can put in our own z-axis in here, and then we're gonna say move all that we've created. Oh, no, don't do that. Like that. I'm gonna disable this one with that one. And suddenly we have glass, although our glass is offset way too much because we put in a 1 meter offset. What's our minimum again? 0.5, 0.05, which is quite close to the edge actually. So let's do it to I don't know, 10 centimeter offset from the edge. Yeah, that works nice. Okay, there we have the glass for that part. Let's give it a nice color by using, actually let me just copy one of these, makes it easier. And like that. Glass is usually blue, I think, isn't it? Well, depends. Unless you go for low iron glass, then they're not really blue. But we can make our glass into low iron by adjusting the alpha that we have in here. Something like that, perhaps. Not all low iron, but low iron enough. Anyway, so let's give it a name. I'm gonna just copy and call this block 1 glass balustrade, like that, and group this into a, whoa, I'll group this into a blue group. Give it a nice blue color. And the good thing about this is I can just copy this without these, shift copy. And what we'll do, oh, actually without these, what I will do is I need to then reconnect this like that, like this. And I'm gonna try to connect it for the second block. Okay, so the first thing we need, floor outlines. Floor outlines came from this one, I believe. Yes, it does. So I'm just gonna do this. Main outline, main outline. Where is my main outline? This one. Copy this one to here. Floor heights. You can see already a glass appearing up there. Floor height, for the floor height, there might be an issue, but we'll see what happens. It's from a series. Yeah, so remember that we adjusted our floor height actually from this one. It was x plus 1. But actually, let's look at the top. The top looks okay. The reason why we didn't do x plus 1 is because we had to exclude that number. But what I suggest to do is bring back the x plus 1, but instead at the output we are going to call the index that we are supposed to leave out. So I'm going to come back in here and say x plus 1. This might create some errors because now we have a duplicate, I believe, duplicate floors. No, because we have now the floors that's on top. Or actually, wait a minute. We skipped the floor, so we actually need to add the value back in here. Actually, let's do it this way then. Let's leave this alone as it was, and we're going to add the floor back into this one. So what we're gonna do is we're actually going to, this one is okay. We're actually gonna do, oh no, we're actually gonna do that. We're going to remove our starting point so that we end up with one less, and I'm gonna actually be using this one instead for our floor heights. There we go. And this should be right up to the top. For this one, we will need a x plus 1 though. Actually, thinking about this, well, well, let's see, what are the data that we need? X floors. These are the, okay, I get it. Okay, I have an idea. I have an idea that's a lot better. Let's just take, where is it? Floor height, and add it to our, oh, we do have floor heights here. Oh, even easier. Oh, that's different floor heights. Floor height and floor heights. There's a difference. What we want to do is I'm gonna actually connect this back to the original. Okay. Sorry for the confusion. Come on. And I'm simply going to, actually, do I need this? Do I need this? Because I already have the data. Okay. I'm just gonna add my own floor. The own floor here, which is a 0, because that's where I should start. I'm just gonna add this to here and there, and then we can connect this. So I'm basically adding back a 0 number into this number list so that we can get that floor that we actually called away for our merge of the overlapping floors. We don't need that here because if you do that here, you'll probably have a glass that's in your, well, that's on the bottom level. So that's a minor difference between a block, oh, we need to change this one also, block 2 and block 1. But this should be the same as for the previous blocks. Oh, I'm gonna actually make this in default color so that I can easily group this into the same color. And now I can actually copy this to the last one. So let's enable our last block. We need floor outlines. Floor outlines comes from a region before region join, which I think is this one. This one. Because we don't want glass to be here. I mean, you can if that's part of your design. This is a list, which is this one. And our floor height is a series, which I drag all the way up here. This one still has the +1 because we don't need to eliminate the, so so this, we might have to disable some of the, we might have to get rid of one layer here because then we have glass that's on top of here. Exactly. So let's do this. Oh, and for block 3, very easy fix. We'll just do call index, and we will be calling 0, not the first, but we're going to reverse our list, reverse this back so that we can call the top floor. A double reversal process again. Let's move this all into nice like that in group and save. And there you have it. The Road 1 residential tower, as far as the the original design and the building of the outer shells. So now you can actually go ahead and play with, oh, you're right, this is temporary. So you can actually keep this temporary or you want to remove it, it's up to you. If you want to remove it, just connect this one to this one and you'll be done. You can just delete this one entirely. So now if you were to say, okay, I want to have a higher floor, then you should define that, or you want to make it into a very bigger tower, let's say 50 radius. Not sure how that will turn out. Hopefully it won't break. Those are big columns, but that's because we specified the amount of columns in that section, which is defined by not this one, but the secondary columns. Where do we define secondary columns? Main column, secondary columns. I think it's somewhere here. Secondary arc setting out. Secondary arc. Oh yeah, we define the columns here. Okay, so we probably want 12. Not too much. 10 is our maximum that we've specified in the sliders, but you can actually change that. So I would say go crazy on it and do a lot of crazy stuff with it. So this is well, the ratio is quite weird, but these are the values that you can all play with and then come up with your own variation of the World 1 tower. So with that ends the tutorial, and I hope you've managed to learn some of the tricks during the course of the tutorial, or maybe learn a lot something new, how you can do certain stuff. Thank you for watching, and I hope you enjoyed it, and look forward to the next tutorial series. Thank you, and bye bye.